My name is Peter Veerman. I am the chair of the Fariborz Maseeh Department of Mathematics and Statistics. I welcome you to the Maseeh Distinguished Lecture in Mathematics. And our distinguished lecturer is David Bressoud. He is the, there's so many things, I have to actually read this off. There's too much. He is the, and this is only a subset. He is the DeWitt Wallace Professor of Mathematics at Macalester College at this moment. He's also the past president of one of the most important associations, professional associations in mathematics, the Mathematical Association of America. One of the things that stand out in his CV for me is that he has served in the Peace Corps in Antigua in the Caribbean. He's written many books, many papers, about 50 papers, and I'm not going to list them. But one of his books, Proofs and Confirmations, has won the Back and Back Award by the MAA. That's the best book prize in mathematics. He's been Polya Lecturer of the MAA, the Mathematical Association of America. He has taught at many places, but among others, the Institute of Advanced Studies, University of Wisconsin, and for 17 years at Penn State, and now he's at the Macalester College. I present to you Professor David Bressoud.
Well, thank you, Peter, and it's quite an honor to be here. And I've been treated very well by the math department, enjoying my stay here in Portland. I think I'm getting an echo off this. Can you turn it? Is that better? Can people hear me okay?
Could you mention that you're in fact this week honorary faculty?
Yes, that's right. I'm honorary faculty member at Portland State. I wonder, this is a small enough group, but are you recording this for future posterity? Okay. So I'll go ahead and use the mic. I do have a voice that easily will fill this room, but I'll go ahead and speak to the mic. One of the issues that's been very important to me, both as a mathematician, as a faculty member, but also as past president of the Math Association, is the entire problem of the transition from high school to college, and in particular getting students into the STEM fields, into science, technology, engineering, and mathematics. This past fall of 2010, there were 210,000 students who entered four-year undergraduate programs. So these are full-time first-year students entering four-year undergraduate programs with the intention of majoring in one of what I consider to be the math-intensive majors. So these are engineering, the physical sciences, including physics, chemistry, geology, or mathematics or statistics. So we had 210,000 students coming in intending to major in one of those fields. About half of them will succeed. And I think that's too high an attrition rate. One of the things that we've been doing at the MAA is collecting data about what happens in the first year. And we managed to get a grant from the National Science Foundation to survey students in Calculus 1, because for all of the math-intensive majors, for most of the science majors, Calculus 1 is a key course. Students have to get through it successfully if they're going to go on and do their science or engineering majors. We surveyed students across all post-secondary institutions, two-year colleges, four-year colleges, small colleges, comprehensive state universities, large research universities. We wound up surveying 700 instructors and over 14,000 students. What we found is that of all the students taking mainstream Calculus 1 this past fall, 2/3 of them had studied calculus in high school. 2/3 of all of them had studied calculus in high school. 2/3 of those who studied calculus in high school had actually taken an AP calculus course. And of those who took an AP calculus course, half of them took the exam and earned a 3 or higher on the exam. in principle, if you earn a 3 or higher on the AP Calculus exam, you qualify for advanced placement. You're ready to go beyond the first course in calculus and start out college with the second course in calculus. Well, you multiply these together, 2/3 times 2/3 times a half, you wind up with 22% of all of the students who were taking Calculus 1 in all of our 2- and 4-year colleges this past fall. 22% of them had earned a 3 or higher on the AP Calculus exam. Now, this is a really good group of students who are taking Calculus 1. One of the other things we found out is that 75% of them, 3/4 of these students, had earned a 610 or higher on the Math SAT. These are bright students. These are what the grades were across the country for this past fall. 22% of these students earned an A, 28% a B, 23% a C, and just over 1/4 of them got a D or an F or withdrew. And one of the things that I find very interesting is that 22% of the students had gotten a 3 or higher on the AP Calculus exam, and that's exactly the percentage that earned an A in the course. Now, it's not clear that taking AP Calculus and earning a 3 or higher is necessary and sufficient for getting an A in the course. But it suggests that there's a very high correlation. That basically the students who are getting an A in Calculus 1 are the students who took calculus in high school and did really well in it. And the students who didn't are not getting those A's. And so what I want to do is talk about the AP Calculus program, and I need a disclaimer at the beginning. I am not here to really criticize the problem, but rather to point out some of the difficulties and problems with the AP Calculus program. And I think I need to begin by telling you a little bit about my own connection to the AP Calculus. Well, first of all, I took the exam back in 1968, and I did pretty well on it. I got a chance to actually teach AP Calculus in the State College area high school. 1990 to 91, I did an exchange with a high school teacher. She taught calculus at Penn State, and I taught AP Calculus in the State College area high school. It was a great introduction to the subject and a wonderful experience for me. I then started going to the AP readings in 1993. I was a reader, a table leader, and a question leader. And then in 1999, I joined the AP Calculus Development Committee. And this is the committee that sets the syllabus for AP Calculus. It writes the examination. It sets the AP Calculus policies and procedures. Joined the committee in 1999, and I chaired that committee for 3 years, from 2002 to 2005. So if you have any problems with the exams that were given in that period, I'm the person to come to and complain to. I think very highly of the program. I think it does a good job of what it was intended to do. But I think that the program is being distorted by this tremendous push to get huge numbers of students into AP Calculus. And just wanted to mention this incidentally. All of these slides are available on my website right now, and I'll put up the URL where you can access these slides at the end of the talk. So you don't have to worry about copying down information. It's all available on my website. But this is an article that I published a little over a year ago in the Chronicle of Higher Education, pointing out many of the problems of the AP Calculus program. The rocky transition from high school calculus, the difficulties that this program actually creates for many of the students who take calculus in high school. Well, this really illustrates the core of the problem. It's the growth of AP Calculus since 1980. All of these numbers are in thousands. In 1980, there were 28,000 students who took the AP Calculus exam. By 1990, that had grown to 78,000. A decade ago, there were 171,000 students who took the exam. And this past spring, 325,000 students took the AP Calculus exam. 325,000. Now, not everybody who studies calculus in high school takes the AP Calculus exam. In fact, we've got good data from the Department of Education. It's over the past decade, it's been pretty consistently around 54% of the students who study calculus in high school of any form, whether it's dual enrollment, IB, some honors calculus, it's 54% of those who take calculus in high school take the examination. Well, with 325,000 taking the examination, that means that we've got over 600,000 students last year, and certainly even more than that this year. The growth rate is about 6% a year. But last year we had over 600,000 students studying calculus in high school. And to give you an idea of what that number means, I mean 600,000 is a lot. We graduate about 3.3 million students from high school in the United States each year. So it's a little less than 20% of all high school graduates have studied calculus in high school. This is not just signing up for the course. It actually means completing and passing the course. We've got about 1.8 million students who are traditional college-bound students in the sense that they go from high school to college within a year of graduation from high school. And most of the students who are taking calculus in high school are traditional college-bound. They are heading to college. They expect to go to college, most of them within the first year after they graduate from high school. So what we're really looking at is a third of the traditional college-bound population is now taking calculus in high school. With all of these students taking calculus in high school, one might expect that there's a tremendous flood of students coming into the STEM fields, into the science, engineering, and mathematics fields, and this shows what's been happening to math-intensive majors. What I've done to adjust for changes in the college-age population is I've taken the number of bachelor's degrees offered in engineering, physical, or earned in engineering, physical science, or mathematics and statistics, and simply divided that by the number of 22-year-olds, so that the numbers are relative to the size of the college-age population. And what we see, engineering's at the top. Back in 1985, it was 1.8% of the population was getting a degree in engineering. It's gone down, almost down to 1.4%. It's back up to 1.6%. But basically, there's been no change over the past 30 years. Essentially no change, either in the percentage of the population that gets a degree in engineering, or in the physical sciences, or in mathematics and statistics. So despite the fact that so many students are going into the calculus, we're not seeing an increase in the number of students coming out and going into these fields. Yes? Right, so I'm not looking at the number of 22-year-olds who have a degree in these fields. I'm simply adjusting for the size of the 22-year-old population. So the actual numbers are total number of bachelor's degrees divided by total number of 22-year-olds. So I thought what I'd do is give you a quick history of AP Calculus so you've got some idea of where it's come from and how we got to this point. And then I'll go on and talk about some of what we know about the ways in which AP Calculus is effective and some of the problems that we know about the growth of AP Calculus. Started back in the 1950s, there actually were a number of movements in the 30s, 40s, and early 50s that were really thinking about this problem of providing opportunities for high school students to really push themselves, to get good high school students and give them some challenging course material. In particular, in mathematics was one of the areas. The AP Calculus program can trace its roots to a program called College Admission with Advanced Standing that really started at Kenyon College. Was the president of Kenyon at the time, Gordon Chalmers. And I actually could only find 2 pictures of him on the web, but this one with Thornton Wilder, why not? So Thornton Wilder makes an appearance in this talk, even though he's not truly relevant to it. But Gordon Chalmers is on the right, and he thought it would be a great idea to put together a program where high school students could study college-level material for the very best and brightest of the high school students. We would give them an opportunity to actually start doing college-level work while they were still in high school. And he got a number of presidents of other institutions on board behind this. Bowdoin, Brown, Carleton, Haverford, Kenyon, MIT, Middlebury, Oberlin, Swarthmore, Wabash, Wesleyan, and Williams all got on board. Faculty from these institutions got together. They had about 6 or 7 different fields of study. One was mathematics. It was not clear initially if the mathematics would be calculus or if it would be advanced algebra and trigonometry, exactly what the topics would be. But they began hashing out what they wanted these students to be able to study. They then went out and contacted some of the best public high schools in the country, places like Central and Philadelphia, and got high schools to agree to sign in on this. And in the fall of 54, they began teaching some of these college-level courses in some of the good public high schools. Spring of 55, they did the first testing of these students, and they actually discovered that good high school students really could do college-level work. 1956, the College Board took over the program at that time. The College Board, of course, had been doing the placement examinations, SAT, and so on. College Board took over this. They rechristened it the Advanced Placement Program. The idea was that these were students taking college-level work so that when they got to college, they could get advanced placement, that they wouldn't have to retake that course that they had studied in college. So 1955, there were about 250 students who took this college admission with advanced standing math exam. And it started growing over the next couple of decades. This shows the growth from the beginning, 250 students in 1955, growing fairly steadily through the 50s and 60s. 1969 is a significant year because that's the year that they broke the calculus exam into 2 pieces. Up through 1968, there was only one AP calculus exam. And basically what colleges did is if you got a 5 on that exam, you got credit for 2 semesters' work. And if you got a 3 or 4 on the exam, you got credit for 1 semester's work. And that didn't always work so well. And they realized that there were a lot of places that didn't want to try to teach an entire year of college calculus, that wanted to focus on just teaching the first semester and spreading that over an entire high school year. So in 1969, they broke the program up into what's known as AB calculus, which basically covers the first semester, actually a bit more than the first semester. It's about 2/3 of a year of calculus because it's got a good deal of integral calculus in it also. So the AB program and the BC program, the AB program, not surprisingly, was much more popular. Students were more interested in just taking 1 semester's worth of college calculus than a full year. But the interesting thing here is that starting in the late 60s, despite the fact that they'd put in 2 examinations, we really had stagnation in the growth. It stopped growing at about that time and into the early 70s. This was not just true of the AP Calculus program, it was true of all of the advanced placement programs. They really seemed to have hit a plateau in the early 70s. Through the 70s and 80s, things really changed in the exam. Up until this point, the examinations were designed for the very best of the best. These students who clearly were bored in the high school classes that were available, and we needed to find challenging material for them to take. One of the things that happened in the 80s, of course, was the movie Stand and Deliver, about Jaime Escalante and his experience in inner city Los Angeles. And this was really symptomatic of a new way of looking at the AP Calculus program as a way of really reaching out to high schools that may have had difficulty getting quality teaching into their schools and trying to leverage it into a quality program by introducing advanced placement programs, challenging these students to do college-level work, and hopefully by doing that to raise the level of the instruction that was going on in the high schools. The College Board, incidentally, plays the heavy in this movie. It's the College Board that, according to the movie at least, is skeptical about these inner city kids who are doing so well in the AP Calculus, and so they come in and accuse them of cheating. And of course, the students retake the exam and they pass it, and it's clear that they really have done it. The College Board did not at all mind playing the heavy in the movie, because this was a tremendous boost to the AP program. It showed that what you really want to do is get lots of good students into this, and if you attract students toward the AP program, it's going to challenge them and raise their academic ability. And there's a lot of good pedagogy behind this. The way to deal with students who are disadvantaged is not to tell them, well, you need to do remedial work. That's not going to motivate them. The way to motivate them is to really challenge them. We're going to have you do excellent work, and get them to think about that. And certainly I admire Jaime Escalante for the work that he did. Even more, over the years, I've gotten to know many of his former students. Many of Escalante's former students went on to get math degrees and then go back to teach in precisely these inner city LA schools that they had come through. And so not only did he do a great job with the students that he taught, there is an ongoing legacy of Jaime Escalante's work. There also were a number of states that saw the advanced placement program as a way of building their state education system. And one of them, Richard Riley, governor of South Carolina during the 80s, he later would go on to be Secretary of Education under President Clinton. Riley was certainly one of the big supporters of the AP program. And so he brought it into South Carolina in a very big way, encouraging his schools to put AP programs into the schools, making sure that students did not have to pay anything in order to take the AP exam. He was followed by many other governors, especially in the southern United States. Many of them in places like Florida actually started paying a bounty. For every student you get into an AP program, we'll pay the high school a little bit extra. Certainly, if you get students to actually take and do well on the exam, very often a bounty would be paid for doing that. And so there was this tremendous push during the 1980s to get AP programs established throughout the country and to get students into them under the belief that if we just get these AP programs going, that's going to raise the academic level of the schools that they're in. And this idea really caught on with the general public. There was a lot of pressure building throughout the 80s from parents who wanted to see their schools offering AP programs, and they wanted to make sure that their children had access to these AP programs and were able to get into them. And there was a feeling that if you really wanted to be ready for college, you needed to start taking these AP programs, and you needed to be in a school that offered as many AP programs as possible. And so the AP program really took off during the 70s and then even more so during the 80s. So the curve across the top is the total number of students taking AP Calculus exams. Below that are the AB exams, and that's where the real growth was taking place. You're establishing a new AP Calculus program in a high school. Almost certainly it's going to be the AB Calculus. The BC continued to grow, but even by 1989, it was barely over 10,000 students a year taking the BC Calculus. Most of the growth was taking place in the AB program. That brings us into the 90s, and a lot happened in the 90s. Part of it was the introduction of graphing calculators. They really started coming in the late 1980s. In the early 90s, the Development Committee and other leaders of the AP Calculus program realized that this was a tool that they really needed to see the schools start to use. 1995 was the first year that the AP Calculus exam not only allowed but actually required students to have a graphing calculator. And the use of graphing calculators in the AP Calculus program really went a long way toward making graphing calculators ubiquitous throughout high school mathematics. If students were going to need to use it in their calculus course, almost certainly they were going to start using it before they got to the calculus course. A number of other changes took place in the 90s. There was a recognition that too many of the questions being asked on the exam were simply rote manipulation. So you learn an algorithmic procedure and you test whether the students have mastered that procedure. So in the 90s, there was really a strong effort toward writing questions that really got at students' conceptual understanding. Much more writing and explanation was expected of the students, rather than just simply working with formulas, finding out if they knew how to differentiate a certain function or integrate a certain function. You were working not just with a symbolic representation, but also verbal descriptions of a situation that had to be modeled using the tools of calculus. Lots of graphical representations of what's going on and making sure that students understand, if they're just looking at a graphical representation of a function, what that is saying. Something else that came in the 1990s was the AB subscore. So up until 1998, you had a choice if you were taking, say, a full year of college-level calculus in high school. At the end of that year, you could either take the AB exam or you could take the BC exam. And if you weren't quite sure that you could do well in the BC exam, it often was safer to take the AB exam, because if you took the BC exam and didn't earn a 3 or higher, well, you might have known a fair amount of calculus, but it didn't show up because you'd simply gotten a 1 or a 2 on the BC exam. So in 1998, the College Board introduced the AB subscore. So there are a significant number of problems on the BC exam that are identical to the problems on the AB exam. Well, enough of them that are essentially AB problems that it's possible to look at these and get a very good idea of what score the student would have gotten if they'd taken the AB exam instead of the BC exam. And this really encouraged a lot of students to go ahead and take the BC exam, even if they weren't entirely confident that they could do well on it, because as long as they did well enough on the AB questions, they could get an AB score that might allow them to get some college credit. Today, 2/3 of the examination is calculator-free. The exam is almost always, in the initial years it wasn't quite this way, but the exam is almost always, since the acceptance of graphing calculators, been divided between questions for which you are allowed to use a graphing calculator and questions for which the graphing calculator must be put away. You're not allowed to use any technology. And today, basically, it's 2/3 of the examination must be done without a calculator. For 1/3 of the examination, you're allowed to use a calculator. Some of those questions where you're allowed to use a calculator, there's no way you actually could use it for advantage, but there are some questions that require knowing how to use the calculator. And one of the interesting things that I've found, the College Board collects data at the end of the examination about which calculators students have used and a little bit about how they used it in their high school classes. And what we found is that the students who do best on the examination are those whose teachers allowed them to use the graphing calculators from 1/4 to half of the time. And the interesting thing is, those are the students who do best on the calculator part, and those are the students who do best on the calculator-free part. The students who do best without a calculator are not the students who were never allowed to use calculators. Now, I've got my own guess as to what's going on here. A teacher who thinks enough about when to allow the students to use calculators and when not to allow them to use calculators is a good teacher. And so I think in part this reflects the quality of the teacher. If a teacher is deciding these are the kinds of questions where I want them to use it, these are the kinds of questions where I don't want them to use it, that's probably a better teacher reflected in better grades for the students. But I do find this interesting that those who are never allowed to use graphing calculators do not do better on the part of the exam where they're not allowed to use the calculator. This is the growth since 1989. We see the growth up to this past spring, 2010, 325,000 exams given. There's a real difference at the point where the AB subscore came in. The BC exams really started to take off at that point. This past spring, there were close to 80,000 students took the BC exam, and just under 250,000 students took the AB exam. The past decade has really seen the AP program become a business. This is under Gasper Caperton, who's been College Board president since 1999. He just recently announced that he will be leaving the College Board a year from now in 2012. And he has really pushed the idea of AP calculus as meeting the requirements of the bottom line. I know those of us who've worked with the AP program, yeah, Mike Boardman is shaking his head, are aware of how they've been cutting costs and squeezing as much out of it as they can. At the same time, really pushing this idea that if you want a quality high school, you've got to have a big AP program. And that's been a prominent message of this past decade. And it's behind a lot of the growth that we've seen. In the past 10 years, calculus in high school has doubled. I mean, these 600,000 students, that's a huge cohort of students. And it's just totally changed the landscape as far as the transition from high school to college is concerned. I want to say a little bit about the AP course audit. This came in 2007, and one of the concerns that there has always been, especially once AP calculus began to grow, is are we getting high-quality teachers teaching the AP calculus program? And there was a lot of pressure to have some kind of certification for these teachers, showing that they really are capable of teaching calculus at a college level, that they understand what they're doing and they're capable of doing it well. And the importance of the teachers cannot be underestimated. These are some data that I actually just found out about a couple days ago. And this is from a study done based on the situation in 2002 in the state of Illinois, looking at the effect of math teacher quality. So they have Illinois put together something they called the Total Quality Index, or TQI, that's a measure of a number of things dealing with the teachers. It's looking at how many years of service they've had. It looks at what institution they got their degree from. It looks at what kind of postgraduate training they've had. It looks at the scores of their students on standardized tests. It also looks at the ACT scores of those teachers. And they put together a total quality index for the math teachers in each of the high schools in the state of Illinois. And then they looked at students who had taken calculus. They actually did this for each of the math courses as the highest math course. But they looked at the students who had taken calculus in these high schools, and they looked at whether or not those students really were ready for college-level work. In theory, any student who has passed calculus in high school, one would expect that they are ready for college-level work when they get to college. But what the state of Illinois found is that if the teachers in the high school, now this is not specifically the calculus teacher, this is the math teachers in the high school as a whole, if they were in the bottom 10% of all teachers in the state, or actually of all high schools in the state, only 50% of the black students who had completed calculus were ready for college-level mathematics. You get the schools where the math teachers were in the 11th to 25th percentile, and it's up to 2/3 of the students, the black students in those schools, were ready for college-level mathematics. Once you get above the bottom quartile, there's not that much variation. So having a teacher in the bottom 10th really does make a significant difference. Not so much once you're above the second quartile, but what's disappointing is even with a really good teacher, it's not all dependent on the teacher. Black students in Illinois, even those with good teachers, only 75% of those who completed calculus were ready for college-level mathematics. The discrepancy is much greater among black students than among white students. There's a slight improvement with the quality of the teacher. The asterisk here is because there are or certainly there were very few white students in Illinois in 2002 who were taking calculus and had teachers who were in the bottom 10th of a percentile, bottom 10 percentile of all teachers in the state. Actually, for the black students, 24% of all black students in Illinois were in high schools where the teachers were in the bottom 10th. So the AP course audit. The quality of the teacher is important, and I and lots of other people were very upset with the College Board for what they did with the AP course audit. What's really needed is some way of measuring the readiness of teachers to teach calculus. And what the AP program did was to ask every teacher to submit their syllabus for the year. And that was the extent of it. They submitted their syllabus, and if it looked like a reasonable syllabus, they were certified to teach AP calculus. Yeah, it would be funny if it weren't so tragic. And I know many good teachers who threatened to leave teaching AP calculus because they were so upset about this. That this is the way the College Board was going to test the readiness of teachers to teach calculus. I want to say a little bit about the National Math and Science Initiative, because that also has been a real important force in AP calculus over the past decade. And I have a love-hate relationship with this initiative. I love it because the main purpose of this initiative, and you may have seen this ad on TV, of this young African-American student who's done an AP calculus program in the high school and is so excited that he's had this chance to really show what he can do. ExxonMobil is behind this in a big way. Bill and Melinda Gates are behind this in a big way. There are many other organizations that are supporting the National Math and Science Initiative. And they've got their heart in the right place, because one of the things that they're focusing on is training good teachers to get into inner city and rural schools and teach the calculus in the way that it needs to be taught. And as we've seen, if you don't have a good teacher teaching the calculus, that has an enormous impact on the students. And so I love the program for doing that, for focusing on getting good people, making sure they're ready to teach the calculus, and then getting them into the schools where they're needed. Where I have problems with this program is that it has tended to reinforce this feeling that you've got to take AP calculus in order to succeed in college. You know, if the inner city black kids who've got promise are going through AP calculus, well, by golly, you know, my son or daughter had better also have access to AP calculus and had better be going through this. And so, while I applaud this program for what it's actually doing, I'm disturbed by the message that it is sending, that you've got to go through calculus in high school in order to succeed in college. And unfortunately, that's becoming a self-fulfilling message. The number of students taking calculus in high school is now so large that, well, as we've seen, 22% took calculus in high school and did really well in it, and that's the percentage of students who are getting A's in the courses. And the students coming into college know this. They know that if they haven't had calculus in high school, they don't stand a chance of succeeding in calculus in college. Now, we who teach in the colleges and universities know that's not true, but the message is out there, and the message is being reinforced by the reality. The students who get the A's are the students who are in a good calculus program in high school. I think this has something to do with a phenomenon that I've observed over the past decade, which is the dramatic drop in the number of African American students going on in mathematics. So this shows what's been happening to African Americans as a percentage of total bachelor's degrees. You go back to 1990, and it was just under 6% of all bachelor's degrees in the United States went to African Americans. That's now getting up close to 10% of all bachelor's degrees are being earned by African Americans. Down here, this is looking at the percentage of engineering degrees, which started near 3% 20 years ago, rose to about 5.5%, but now has dropped off in the past decade to less than 5% of engineering degrees are earned by African Americans. In the case of physical science degrees, that rose to a high of close to 6.5%. It's now back below 6%. But what's really dramatic is what's been happening with math degrees. Throughout the 90s, African Americans were well represented in math programs. So their representation among math degrees was very close and occasionally slightly above their representation among all bachelor's degrees. But around the end of the 90s, that changed dramatically, and we've actually seen a 20%, slightly over a 20% drop in the actual number of African Americans, both men and women, who are earning bachelor's degrees in mathematics or statistics. And I think that part of what is driving this is this feeling among students that if you haven't had access to a good calculus program in high school, you don't stand a chance of going into a program that relies on calculus when you get to college. And certainly you're not prepared for a math program. That's a message that I wish we weren't sending, but we are. And so the National Math and Science Initiative really is essential, because we can't reverse what has happened. And the only thing we can really do at this point is go forward and try to raise the level of those who are teaching calculus in the high schools. And so in that sense, it's needed. But I also worry about the message, and I'm going to have some suggestions for things that can be done. But let me first talk a little bit about the research that we do have on the effectiveness of AP Calculus. There have been a few studies that are really meaningful. Of course, there are lots of people who've observed students who take calculus in high school do a lot better in college than those who haven't. Well, of course, because it's the best students who take calculus in high school. So you expect that they're going to do better. But is there actually any benefit from taking calculus in high school? And if a student scores a 3 or higher on the AP Calculus exam, are they really ready for advanced placement? Have they done at least as well as the students who took the first semester of calculus in college? And the studies that we have show that, in fact, they are ready. One of the problems is that the data that we have are all old. So one of the most important studies is the Morgan and Clarick study. It was published in 2007, but it's based on data gathered in 1994. It takes a long time to get these studies published. But what it shows is that the students who did well, even a 3 on the AB exam, they did better when they went straight into the second semester of calculus than the students who had simply passed the first semester of calculus. This was a large-scale study done at a large number of institutions. There was another study done just using students at the University of Texas, Austin. It was done with the fall classes in calculus over 4 years, 1998 through 2001. Study was published in 2008, and it showed essentially the same thing. If you've gotten a 3 or higher on the AB exam, you're going to do at least as well if you go straight into the second semester of calculus as those students who've been through the first semester of calculus at that institution. And one of the interesting things that they found was that students who earned a 3 or higher on the AB exam and chose to retake Calculus 1 actually did slightly worse than the students who went on and went directly to Calculus 2. Now, there's some problems with this bit of information. For one thing, the difference was statistically significant in only 1 of the 4 years. But the other big problem is that you didn't control for comparability of ability levels of these two populations. And certainly there is a difference between those who earn a 3 or higher and are confident enough to go on directly into Calculus 2, and those who earned a 3 or higher and felt that they needed to retake Calculus 1. So I'm not sure that that really says that you'll always do better if you go straight into Calculus 2 than if you retake Calculus 1. But it does suggest that there's no strong indication that you would do better to retake Calculus 1 than to go on into Calculus 2 if you feel you're ready for the Calculus 2. There also is an interesting study done by Phil Sadler out of Harvard, Factors Influencing College Success in Science. And what he found is that the students who study calculus in high school and do well, so we're looking at the students who study calculus in high school and then earn a 3 or higher on the AB exam. They not only do significantly better when they take calculus, he was looking specifically at performance in Calculus 1, but they also did significantly better, even controlling for student ability, socioeconomic status, and so on. They did considerably better in introductory biology, introductory chemistry, and introductory physics. That there is this kind of add-on effect. If you're taking a good calculus course in high school and you're doing well in that course, it really does give you an advantage when you get to college. What he also found is that there was little or no discernible benefit from simply taking calculus in high school. And I have yet to see a study that convinces me that there is any benefit to taking calculus in high school if you're not going to do it well enough that you can do well on the AP Calculus exam. Simply sitting in on a calculus course does not give you any advantage that I have seen. I haven't seen any studies that show any advantage simply from moving into calculus. There is some indication that it may actually be disadvantageous. We don't have enough information about these students. But the U.S. Department of Education, every 10 years, they do a large-scale longitudinal study. They did one that started in 1988, looking at the high school class of 1992. There was another one that started with the high school class of 2004. And there's one that they've just begun that is looking at the high school class of 2012. In each case, they're looking at about 20 to 22,000 students from across the country, and they're doing thorough transcript analysis as well as many other survey questions. They follow these students from about 9th, 10th grade right up through age 26, 27, 28. And look at all of the courses that they take and how they perform in those courses. Now, we've got good data. The study for the high school class of 1992 is complete, and we've got that data. For the high school class of 2004, the final transcript analysis won't be begun until next year. So it takes 10 years after the students graduate from high school before we know the picture of what effect their high school experience had on their following academic career. But of the high school class of 1992, those who got credit for calculus while in high school, that is to say they passed their high school calculus class, almost a third of them then took pre-calculus when they got to college. And almost another third took neither pre-calculus nor calculus when they got to college. Now, I'm particularly worried about these students because these are students who were told in high school, you're one of the best. You're ready to do college-level work. And then they get to college and they're told, not only will you not give you credit for your college level work, you're not even ready to start calculus. You have to back up and take pre-calculus again. Now, we know that that's true. There are lots of students who come into our institutions who may have taken calculus, past calculus in high school, and aren't ready for it. It disturbs me that it was that high, and that was 20 years ago. That was 20 years ago when there were only a quarter as many people studying calculus in high school. We've now got 4 times as many people as that taking calculus in high school. I'm afraid this number is significantly higher. What we do know from the class of 2004, of those who took calculus in high school, 17% self-reported that they then took remedial mathematics when they got to college. Now, you need to take that with a grain of salt because there was a survey question. Did you take remedial mathematics in college without a definition of what's meant by remedial mathematics? So for some of them, it might have meant a non-credit-bearing course, an intermediate algebra course. Some students might have seen college algebra as remedial, but almost certainly it means that they're taking a course that at least they considered to be a remedial mathematics course. So there is evidence that there is a substantial population of students who are being pushed into calculus in high school who really are not ready for it. They need to back up several steps when they get to college. And this is enormously discouraging. Certainly I have lots of anecdotal evidence of students who thought they were good in mathematics until they got to college and took the placement examination, were thinking of going into a science or engineering field, and gave up on that dream because of the message. Yes? That means that they got credit on their high school transcript, that they got, high school credit. Yeah.
How many of those passed the
I am assuming that, that they, well, again, by earning credit, I just mean it was high school, that they passed their high school course, not that they got college credit. So there's no finer breakdown of these students, how many of them were in AP Calculus or how they did on an AP Calculus exam. Yes?
Are these students that are taking calculus going into college directly after high school still, or do you maybe wait a little while?
They might have waited a while, but most of the students, again, who take calculus in high school are bound to college pretty directly. Yeah?
Did anybody ask how much beer these kids have been drinking? I mean, some kids go to high school, they're at home, and they have to work, but then they go off to college and they party.
Sure, yeah. And there's certainly, excuse me, there are a lot of students who choose to take the pre-calculus because they think it'll be a lot easier. And there's not much you can do about that. But I do believe that we need clear, enforced guidelines for what it means to be ready for calculus. And I'd love to see these put in place and some kind of screening so that we're sure that the students who are taking calculus in high school are not taking it just because their cohort is taking it. Talking with undergraduates and even graduate students, so many of them say they took high school in calculus because that's what all their friends were doing. Never occurred to them whether or not they should. And we need some way of checking whether or not these students really are ready. There is no program in place whatsoever across the country, perhaps in some select high schools, but no national, no widespread program to check whether or not students are ready to take calculus in high school, and that's what we need. So I'd like to finish up with several points. One, we've reached the point now where so many people are taking calculus in high school that those who do not have access to a good calculus program in high school are at a serious disadvantage if they're interested in going on in engineering or science. Secondly, high teacher quality is essential. It's not enough to just have a program that's called AP Calculus. It's not enough to have a syllabus that's been approved by the College Board. We really need teachers who know what they're doing, who understand the calculus, who understand how to teach calculus effectively. We also need to screen students to ensure that they are prepared for calculus in high school. We also need strong alternatives for these students. If it's shown that you're not yet ready to really do calculus, we need the courses in place that deepen their algebraic skills, their understanding of trigonometry. I've run across a number of students, now undergraduates, who had 6 weeks of trigonometry in high school. And that's all the trigonometry that they've seen. And they're not ready for college-level mathematics if that's all the trigonometry that they've seen. And so we need alternatives. And one of the problems is that the AP program has become so ubiquitous that there's the assumption that any student with any kind of mathematical ability is going to be pushed into AP Calculus. And we really need strong alternatives to that. All the evidence we have suggests that calculus in high school does work well for the top 200,000. We've got about 600,000 students taking calculus in high school. That top third, some of them are going to get a 3 or higher and go directly into an upper some calculus course beyond Calculus 1. Some of these students are going to get a 3 and higher. They're going to get credit for college calculus, and they're never going to darken the door of a math course again. They've got their college credit for calculus, and they're going to avoid taking mathematics in college, and that's fine. They've done well. They've gotten an experience of calculus. I don't worry about those. We've also got the students who take calculus in high school, do well in it, and then use that to translate into an A in Calculus 1 when they get to college. I consider those to be successes also. But what I worry about are the other 400,000 students, and these are not weak students. This is the bottom two-thirds. I mean, what we're talking about, the bottom two-thirds of the top 600,000 students. Basically, the top 8% of college graduates, that's that top 200,000. Here we're looking at the next 16% of our high school graduates. This is not a group we want to put at risk. And we are putting them at risk if we're pushing them into calculus in high school before they're ready for it. So again, this is the URL for my talk. And I want to thank you for this opportunity to share my concerns with you, and I'll gladly answer any other questions that people have. Thank you.
Are there any other questions? Yes.
You hinted at this, but I think almost everyone in this room knows there are other branches of mathematics which are woefully abandoned in high school. I mean, I don't know how much graph theory, for example, which is something that would be excellent if you're planning to do some computation later. Or an awful lot of kids get through high school without taking any statistics except for a 2-week unit someplace in Math 3. How much? What are similar numbers? Is there anything like AP for general math?
Well, there is an AP statistics program, and that's been growing quite quickly. That's now over 100,000 students take the AP statistics exam each year.
Right, but how about AP broader math?
There is no other AP math, and the College Board is pretty adamant that there will not be any other advanced placement math courses. And that's going to be one of the problems as we think about putting courses in place that are alternatives to calculus. And you're absolutely right. There's lots of other great mathematics. The Educational Development Corporation in Boston, Alquoco, is working on a high school linear algebra course, which is a wonderful course for high school students that really broadens algebraic skills and gives them a broader sense brings in a lot of geometric concepts, but I'm not sure how well he can sell this. What he's really selling it are to the students who take AP Calculus before their senior year and now need another course to take in their senior year. And that actually is also becoming a problem. We've now got about 75,000 students in the country who take AP Calculus who take the AP Calculus exam before their senior year. So we keep pushing these courses earlier and earlier in the curriculum. Students are getting accelerated, and what is happening often is that in order to teach these courses, say calculus to 11th graders, it's no longer the kind of calculus that you would want to be teaching. But yeah, there are lots of opportunities for other kinds of mathematics that could be brought into the high schools. The problem is, how do you convince the high schools to build these programs? And I think one of the ways of doing it is by screening the students. If you convince the high schools that they've got a large number of talented students who shouldn't go on into calculus, those high schools are going to find alternatives for those students. But not unless we put some kind of barrier in the way of simply letting them move into calculus automatically. Yeah?
Do you have data for any other minority students?
Well, for Hispanic students, the pattern is similar, not as dramatic as for African Americans, but also for Hispanic students, also for women. The past decade has seen a decline in the percentage of women in engineering, in the physical sciences, and in mathematics, also for Hispanic students. Now, to some extent, Hispanic students, there's been a tremendous growth in the number of Hispanic students going on to college. But they have not been keeping up to their general growth as a part of the college population in terms of their population in science and engineering. So we've got a widening gap there, and we've got actually declines in women. And so I think a lot of this push to get the higher mathematics into earlier and earlier grades seems to be working pretty well for white males, but not so much for other populations.
Don't forget Asians.
Well, yeah. Yes? We don't know nearly as much about AP stats, partly because they're such a recent phenomena. They didn't start up until the mid-90s, and there haven't been significant numbers until very recently. Also, the AP stats is somewhat different because the high school statistics program is not directly comparable to many of the introductory college programs. So what we do at Macalester, and I think this is pretty common, is a student who does well on AP statistics gets college credit, but they don't necessarily get advanced placement when they come into college. And so it plays a different role than the calculus does. Yeah? Well, I do believe in the Common Core State Standards. I think that it's a good first step toward strengthening K-12 mathematics education. A lot is going to depend on how these standards actually are implemented, how they translate into textbooks, into teacher preparation, into ongoing teacher support. But this general push of courses into ever earlier grades, we see that all along the line, including the push of Algebra 1 into 8th grade. There are a lot of students who are ready for Algebra 1 in 8th grade, and there are a lot of schools that do have good teachers who are ready to teach Algebra 1 the way it should be taught in 8th grade. But there also are students who are not ready for it, and there are schools where the 8th grade teachers are not prepared to teach Algebra 1 the way it needs to be taught. And so we're seeing some of that effect also in the earlier grades. But there's a general push to get these courses. And of course, Algebra 1 in 8th grade is now common enough that if you've got a really bright son or daughter, you want them to be getting Algebra 1 in 7th grade or 6th grade. And so it just keeps pushing everything earlier and earlier.
Shall we thank the speaker one more time?
Okay.